Python tuples, an introduction. Tuples are a way to store multiple items together in Python. They are like lists, but you cannot change their contents after creation. Let us explore how to use tuples, where they are useful, and common techniques. Running the cell now. We start by turning off all warnings for this lesson. We import the warnings module so warnings do not distract us. Import numpy as np. We set the random seed to 42 for reproducibility. This line disables warnings while we code. Let us define a tuple to group some basic information. Tuples can store data of different types together. This tuple puts a name, an age, and a job title together. Notice the parentheses. Printing shows us the tuple's complete content. Running the cell now. This output shows a tuple containing 3 fixed elements, a name, an age, and a profession. Notice how the tuple stores different data types together, but unlike lists, its contents cannot be modified after creation. This demonstrates the tuple's role as a simple, immutable collection in Python. Tuple basics. Tuples use parentheses, item 1, item 2. You can store any number of items, different data types are fine. Once created, you cannot change what is inside a tuple. Running the cell now. Let us see some tuple examples. This line is a comment explaining that we are defining a tuple of colors. Here we create a tuple named colors that contains 3 color strings. This prints the contents of the colors tuple to the console. This comment explains that tuples can contain different data types like numbers and strings. We define a tuple named info that contains an integer, a string, and a boolean. This prints the contents of the info tuple to the console. Running the cell now. Here, the output shows 2 tuples, one with 3 color names and another mixing a number, string, and boolean. Notice the use of parentheses to group the items, highlighting that tuples can hold multiple and different data types. This demonstrates the core tuple concept, fixed collections that preserve order and types once created. Empty and single-item tuples look special. Tuples can be empty or contain multiple items. This creates an empty tuple using empty parentheses. This creates a single-item tuple. The comma distinguishes it from just a number in parentheses. This prints both tuples to show their contents. Running the cell now. Here we see 2 tuples, an empty one with no items, shown as, and a single-item tuple containing 42, shown as 42. Notice the comma after 42, this is necessary to define it as a tuple with one element rather than just a number in parentheses. This demonstrates how tuple syntax works for different sizes. Accessing tuple elements. Tuples are like collections. To get an item, use its position, an index number. Python counts positions from 0. Running the cell now. Let us get items out of a tuple by their positions. This line is a comment explaining that we will get items from the list by their index. We assign the first item in the list colors to the variables first_color using index 0. We assign the second item in the list colors to the variable second_color using index 1. We print the value stored in first_color to display the first color. We print the value stored in second_color to display the second color. Running the cell now. This output shows how to access specific items in a tuple using their index positions. Notice that colors 0 retrieves the first element, red, and colors 1 retrieves the second element, green, demonstrating that Python starts counting from 0. This confirms the lesson's key idea: to get items from a tuple, you reference their position by index. Negative numbers let us start counting from the end. This line is a comment explaining that we will access the last item of a list or tuple using a negative index. We assign the last element of the colors list, or tuple, to the variable last_color using the negative index -1. we print the string last color followed by the value stored in last_color to display the last color. Running the cell now. Here, the code accesses the last item in the tuple using a negative index, -1, which means start counting from the end. Notice that instead of counting forward from 0, it retrieves blue, the last color in the tuple. This demonstrates how negative indexing provides a convenient shortcut to access elements from the end of a collection. Tuple slicing, get multiple values. You can take parts of a tuple using a slice, just like with lists. A slice gives you a new tuple with the items you want. Running the cell now. Let us see how to grab part of a tuple. We are showing how to slice a tuple by selecting a subset of its elements. We create a new tuple mid_colors that includes elements from index 0 up to, but not including, index 2 of colors. We display the contents of mid_colors to see the sliced portion of the tuple. Running the cell now. Here, the code slices the colors tuple to extract the first two items, producing a new tuple, red, green. Notice that slicing preserves the tuple format and order, giving you a specific segment without modifying the original tuple. This shows how tuple slicing lets you access multiple values at once efficiently. You can use negative indices to slice from the end. This is a comment explaining that the next line uses slicing with negative indices. The variable tail is assigned the last two elements of the tuple's colors. We print the value of for tail to show the last two items in the tuple. Running the cell now. This output shows the result of slicing the last two items from the colors tuple using negative indices. Notice how colors -2 happy smiley grabs a new tuple with the last two elements green and blue, demonstrating how tuple slicing works similarly to lists. This confirms that slicing with negative indices efficiently retrieves elements from the end. Immutability, what you cannot do with tuples. Tuples cannot be changed in place. You cannot add, remove, or adjust their items after creation. Trying this causes errors. Running the cell now. Here is an example of something tuples do not allow. This line is commented out. If you try it, Python will say you cannot make that change. If you remove the comment mark, you will see an error message about assignment. Running the cell now. This code produces no output because attempting to change an item in a tuple is not allowed and results in an error, which is why the modification line is commented out. This demonstrates the key lesson: tuples are immutable, so you cannot alter their contents once created. Noticing the absence of output highlights that any such change attempts will halt your program with an error. Unlike lists, tuples have no methods for adding or removing things. Tuples do not offer append or remove like lists. These lines would fail. If you try to append, Python says that this method does not exist. Trying to remove an item does not work for tuples either. Running the cell now. This code intentionally avoids producing output because it demonstrates that tuples lack methods like append or remove. Attempting to modify a tuple this way results in errors, reinforcing the concept of immutability. Tuples cannot be changed after creation. Notice that no changes or outputs occur, highlighting that such operations are not allowed. Tuple built-in functions. Although you cannot change a tuple, you can use useful built-in functions with them. Let us try len, minute, max, and sum. Running the cell now. Now let us see what built-in functions can do for tuples. These lines provide useful functions to work with tuples of numbers. Here, we define a tuple named numbers containing for integers. We print the length of the tuple, which shows how many items are inside. We print the smallest number found in the tuple. We print the largest number found in the tuple. We print the sum of all the numbers in the tuple. Running the cell now. This output shows how built-in functions provide quick insights into a tuple of numbers. Len returns the total count of elements, while minute, max, and sum identify key values and the total sum. Notice that despite tuples being immutable, these functions help us analyze their contents efficiently, which is the main purpose of this lesson section. It is easy to see if something is in a tuple. This line comments that you can use the in keyword to check if an element exists in a container. This line prints true or false depending on whether the string green is in the variable colors. This line prints true or false depending on whether the string yellow is in the variable colors. Running the cell now. Here, the code uses the in keyword to check if certain items exist within the tuple colors. The output shows true for green because it is present in the tuple, and false for yellow because it is not. This demonstrates an easy way to verify membership in a tuple without modifying it. Tuple methods, count, and index. Tuples offer only two methods, count and index. Count tells you how many times a value appears. Index tells you the first position of a chosen value. Running the cell now. Let us see both methods in practice. This line is a comment explaining that we'll use the count and index methods with tuples. Here, we define a tuple called fruits containing several fruit names, including duplicates. We use the count method to find out how many times apples appears in the tuple. We use the index method to find the first position where a pear appears in the tuple. We print the number of apples found in the tuple. We print the position of the first pear in the tuple, noting that counting starts at 0. Running the cell now. This output shows how tuple methods work. Count finds that apple appears twice in the tuple, while index locates pear at position 1, the second item. Notice how these methods help us quickly analyze tuple contents by providing counts and positions, which is exactly the lesson's goal. Sometimes, searching for a value that does not exist gives you an error. If you try to find the index of a value not in the tuple, Python will stop and give you a value error. This reminds us to be sure something is present before looking for it with index. Running the cell now. Here, we highlight that using index on a value not in the tuple causes a value error. This reinforces the lesson point that index returns the first position of a value, but you must ensure the value exists first or handle the potential error. It teaches careful use of index to avoid runtime issues. Real-world example, coordinates as tuples. Tuples are great for things like coordinates or small fixed sets. Let us work with an example for points on a map. Running the cell now. Here we use a tuple to store the position of a place. This comment explains that a tuple is used to store a coordinate consisting of latitude and longitude. Here, a tuple named school_location is assigned specific latitude and longitude values. This line prints a message and the values stored in the school_location tuple. Running the cell now. This output shows a tuple storing a fixed pair of coordinates, representing latitude and longitude for a school location. Notice how tuples neatly group related, unchanging data, perfect for geographic points. This highlights the lesson's intent to use tuples for compact, immutable sets like map coordinates. You can split a tuple into separate values easily. This comment describes the action of unpacking a tuple into separate variables. Here, we assign the first and second elements of the tuple school_location to a lat and lon respectively. This prints the text latitude followed by the value stored in a lat. This prints the text longitude followed by the value stored in lon. Running the cell now. This output shows how the tuple school_location is unpacked into two variables, lat and lon, representing latitude and longitude coordinates. Notice how the code cleanly separates these fixed values, illustrating the convenience of tuples for handling small, related data like points on a map. This reinforces the lesson's intent to use tuples for organized, easy-to-access coordinate data. Tuple packing and unpacking. Packing is when we collect values into a tuple. Unpacking is when we split a tuple into variables. Running the cell now. Now let us try packing and unpacking values. We start with two variables, a and b. Assign the value 5 to the variable a. Assign the value 8 to the variable b. Create a tuple p containing a and b. This is packing. Print the packed tuple p. Unpack the tuple p by assigning its values to x and y. Print the unpacked values x and y to check they match a and b. Running the cell now. This output shows tuple packing and unpacking in action. The values 5 and 8 are first packed into a single tuple, 5, 8, then unpacked back into separate variables x and y. Notice how the original values are preserved in the tuple structure and correctly assigned back, demonstrating how tuples can group and distribute data efficiently. This reinforces the intent to handle multiple values cleanly in Python. Swapping variables using tuples. Python lets you swap variable values with tuple unpacking. It is a common shortcut in coding. Running the cell now. Let us use a tuple to swap data. This comment explains that the following code swaps two variables. We assign the value 1 to the variable a. We assign the value 2 to the variable b. We swap the values of a and b using tuple unpacking. We print the values of a and b to verify they were swapped. Running the cell now. Here, the output shows that the values of variables a and b have successfully swapped, with a now holding 2 and b holding 1. This demonstrates the power of tuple unpacking in Python, which allows swapping without needing a temporary variable, a common and efficient coding shortcut. Tuples are useful as dictionary keys, since their values do not change. Here we make a tuple for a point, then use it as a key for a dictionary. This is possible because tuples cannot change, keeping our keys safe. We make an empty dictionary. After adding the tuple as a key, we set its value to a place name. Printing the dictionary shows the tuple key and its matching value. Running the cell now. Here, the code demonstrates how a tuple can be used as a key in a dictionary, with the point 10, 20 mapped to the value spark. This shows tuples are immutable and suitable as dictionary keys, reinforcing their role in Python beyond just swapping variable values. Understanding tuples as fixed, hashable sequences helps you appreciate their flexibility in different coding contexts. When to use tuples. Use tuples when your data should not change. For example, for the x, y, coordinates, fixed colors, or dates. Running the cell now. Here is a good use for a tuple. This line is a comment explaining the example shown below. This line creates a tuple named birthday with a day and month. This line prints the label and the birthday tuple to show the contents. Running the cell now. Here, the output shows a tuple representing a birthday with a fixed day and month, 23, July. The key point is that tuples keep these values unchanged, making them ideal for storing data like dates that should remain constant. This example emphasizes using tuples when you want to ensure your data, such as a birthday, is not accidentally modified. Tuples are handy for returning more than one value from a function. This is a comment explaining the example of a function that returns a tuple. Define a function named minute underscore and underscore max that takes a list called values. The function returns a tuple containing the smallest and largest values from the list. Create a list of numbers called nums. Call the minute underscore and underscore max function with nums and store the result. Print the minimum and maximum values from the result tuple. Running the cell now. This output shows how a tuple can neatly return multiple values from a function, in this case, the minimum and maximum of a list. Notice the fixed order in the tuple lets us access the minimum with result 0 and maximum with result 1, demonstrating tuples' usefulness for grouping related but unchangeable data. This reinforces the lesson's point about using tuples when you want to return multiple pieces of data that shouldn't be modified. Miniproject, counting unique coordinates. Let us count unique point locations from a list of coordinates using tuples. Running the cell now. We use tuples inside a list and remove duplicates fast. This line is a comment explaining that the next line lists coordinates as tuples. Here we create a list named points containing for tuples representing coordinates. This comment tells us we will convert the list to a set to remove duplicate entries. We convert the points list to a set called unique_points to keep only unique coordinate tuples. This line prints the set of unique coordinates to show the distinct points. Finally, we print the number of unique points by finding the length of the set. Running the cell now. The output shows the unique coordinates extracted from the original list, with duplicates removed by converting to a set. Notice that the count reflects only distinct points, confirming the intent to identify and count unique locations efficiently using tuples and sets. Let us sort a list of tuples. This line is a comment explaining that we're sorting a list of tuples by the first item. Here we create a list of tuples, each with a number and a direction string. This line sorts the list in place based on the first item of each tuple. Finally, we print the sorted list of tuples to see the result. Running the cell now. Here, the code sorts a list of coordinate tuples by their first item, which is the numeric value. Notice how the output shows the tuples reordered from smallest to largest number, demonstrating how sorting helps organize data for easier counting or searching in later steps. This reinforces how tuples can be manipulated while preserving their paired information. Best practices with tuples. Use tuples when order matters and changes are not needed. Use lists if you must update or expand your sequence. Running the cell now. It is easy to think that one set of parentheses is enough, but Python needs a comma for single-item tuples. This is a comment explaining a common mistake with single-item tuples. Here, parentheses around 5 do not create a tuple without a comma. This line prints the type of single, showing it's an int, not a tuple. Adding a comma creates a single-item tuple as intended. This prints the type confirming single_tuple is now a tuple. Running the cell now. Here, the output highlights a common pitfall. Without a comma, 5 is just an integer in parentheses, not a tuple. Notice how adding the comma ensures the type is recognized as a tuple, reinforcing the lesson that tuples require that trailing comma when containing a single item. This distinction is crucial for maintaining correct data structures when order matters and immutability is desired. Now it is your turn to make a tuple from some user input. This line is a comment describing the challenge to create a tuple from user input. We prompt the user to enter their favorite color and save the response in the variable color. We ask the user to enter their lucky number and store that input in number. We create a tuple named favorite that contains the color and number variables. We print a message followed by the favorite tuple to show the user's input combined. Running the cell now. This output shows a tuple containing two user inputs, a color and a number. Notice how the tuple preserves the order and groups these related values together without allowing changes later. This example highlights the lesson's point that tuples are ideal when you need an ordered, fixed collection of items. Unpack user input into a tuple, step by step. Describe the challenge of unpacking tuples from user input. Ask the user to type two words separated by space. Split the input string into two separate words and assign them to word 1 and word 2. Create a tuple containing word 1 and word 2. Print the tuple to show the unpacked values clearly. Running the cell now. This output shows that the user's input hello world was successfully split into two separate strings and packed into a tuple, maintaining the order exactly as typed. Notice how tuple unpacking neatly captures each word into distinct variables, demonstrating the lesson's point that tuples are ideal when you want to preserve order without modifying the sequence later. Let us make a simple guess game with a tuple. Provide a brief description of the challenge. Create a tuple containing several fruit names. Prompt the user to enter a guess for a fruit. Check if the user's guess is one of the fruits in the tuple. If it is, print a message confirming the guess. Otherwise, print a message indicating the guess is not in the tuple. End the conditional block. Running the cell now. This output shows that the user's input matched one of the items in the tuple fruits, confirming the presence check worked correctly. Notice how the code leverages the immutability and fixed order of a tuple to efficiently check membership without needing modifications. This reinforces the lesson that tuples are ideal when you want a fixed sequence to test values against without updating them. Print each value from a tuple using a loop. This comment explains the challenge to find and print each item using a for loop. We create a tuple named numbers containing for integers. This for loop goes through each number in the numbers tuple one at a time. Inside the loop, we print the current number on its own line. Running the cell now. This output shows each number from the tuple printed on its own line, confirming that tuples can be efficiently iterated over in order. Since the tuple's contents don't change, using a tuple here enforces the best practice of keeping ordered data immutable when no updates are needed. Notice how the for loop accesses each element sequentially, demonstrating tuple traversal without modification. Let us count how many vowels are in a word, using a tuple to hold the vowels. Explain the programming challenge to count vowels using a tuple. Prompt the user to enter a word. Create a tuple containing all vowel characters. Initialize the vowel count to 0. Start looping through each character in the word. Check if the current character is a vowel, ignoring case. Increment the count if the character is a vowel. Output the total number of vowels found in the input word. Running the cell now. This output shows the total number of vowels found in the user's input word, based on checking each character against the fixed tuple of vowels. Notice how the tuple ensures the vowel set is ordered and unchangeable throughout the loop, reinforcing the lesson's point that tuples are ideal when you need a constant sequence for membership checks. The key takeaway is how using a tuple here simplifies the code while preserving the integrity of the vowel list. Recap: what did we learn about tuples? Tuples help you group values together, safely and in order. They are fast, safe for keys, and great for returning more than one value from a function. Remember, tuples do not change after creation. Use them when you need fixed groups of data. Running the cell now. Keep practicing. Try making your own tuples, and find more uses when data should not change. Like this video and subscribe for more beginner Python tips. Running the cell now.